First page, sir.
Is it visible, sir?
Yes. Yes, sir. Sir, before starting, dear participants, I would like to introduce our speaker of this session, day 2, session 4, Dr. Sandeep Dahake, sir. Sandeep Dahake, sir, is a Chief Executive Officer and founder of Precise Private Limited. It is an incubator center at the Visvesvaraya National Institute of Technology, Nagpur, VNIT, Nagpur. He has completed his B and MTech in CAD/CAM specialization from RTMNU University. He has also completed his PhD from the VNIT Nagpur in biomedical and rapid prototyping domain. He has completed he was also a fellow in the postdoctoral at VNIT Nagpur. Having around 13 years of experience in biomedical research, he has published more than 15 SCI journals, Scopus journals, and 6 patents has already been granted in the national. And in international, 1 patent has already been filed and many book chapters has already been published. Received BIRAC Biotechnology Ignition Grant in 2019 from DBT of rupees 50 lakh. Received MIMICS Innovation Award 2020 from Metallized Belgium of 1000 euros. They received News and IEDC DMIMS grant in 2021 from NST EDB DST of India of 25 lakh rupees. Received Nidhi Prayas grant in 2022 from IIT Bombay of 10 lakh rupees. He also received TVDC Technology Development Validation and Commercialization Grant in 2022 from NRDC of 89 lakh rupees. His research area includes CAD/CAM, 3D printing, 3D scanning, custom medical services, product design and development. He has vast knowledge in 3D printing and additive manufacturing in context of Industry 4.0. He is going to elaborate or discuss the idea on additive manufacturing in Industry 4.0. Over to you, sir.
Very good afternoon, and thank you for nice introduction. The today's topic uh, is related to 3D printing or additive manufacturing, and again, the role of that additive manufacturing in the industry 4.0. I am a person from biomedical domain. I work from last. I am working actually last three around 13 to 15 years in the domain of biomedical for development of various custom products in the medical industries. So today I will discuss the how this additive manufacturing is important in the industry 4.0 related to the medical domain for development of various custom products. So in my today's presentation, I will discuss the industrial revolutions, then different components which are related to Industry 4.0, role of additive manufacturing, then challenges, and the most important is the what are the different applications which are related to the additive manufacturing, again related to Industry 4.0, and particularly it is for the medical sectors. So, as you have known, what is the industrial revolution? In the first industrial revolution, it is started in between 1760 to the 1840. So most of the work has been done in this revolution. It is related to the comfortness of the humans, and for that they have upgraded the manual production into a uh, to give the comfort by using different technologies like They have generated steam powered engines, and particularly the agenda of using this type of engines to provide the comfort i- to the humans. So basically, in the first industrial revolution, they mostly upgraded the textile industries as well as the agricultural field. So the agenda of first industrial revolution was to provide the comfort by providing this type of applications like steam powered engines. In the second industrial revolution, which was basically started to 1870s to the 1940s, they basically provided the facility of railroads and telegraphs. The focus was to produce the standard parts, involution of the inspection, focus on the quality control to develop a qualitative parts, then to increase the speed of the production. But they face the problem of flexibility in the designing and manufacturing. Also, in the second revolution, they introduced the concept of mass production in the industry. So, till the second industrial revolution, the concept of mass production started and using in various industries. But when you see the third industrial revolution, which we have seen in um, previous years, which was started basically from 1950, this revolution focuses mostly to increase the speed, flexibility. They are using different robots, then automation programs likewise. They also incorporated various digital technologies in the production system, introduces machines, smart machines like 3D printers, CNC machines, then different robots. They also taken the support of various network systems, software technologies to upgrade the production, to upgrade the automation. Also, they amalgamate various computers, IT sectors to improve the productivity as well as the quality of the product. Also, they have slightly focused on the flexibility and custom manufacturing in different sectors. And the most important, they introduce the CAD/CAM technology extensively for the development of products in various sectors. So, in the third industrial revolution, they started the using of the smart technologies like 3D printing, CNC machining, robots. They also tried to involve computer communications technologies, then various information technology for the development of the smart advanced products as well as to improve the productivity. Now, it is the era of the third industrial revolution, and the most challenges in the industrial fourth industrial revolution is the automation for the intelligent manufacturing. Automation for the intelligent manufacturing. So, they are taking the help of various advanced technologies like additive manufacturing, internet of the things, industrial internet of the things, artificial intelligence, automatic robots. So these are the smart technologies, and by taking the help of these different technologies, they are using to improve the productivity, mass customization, and flexible product development. So, in the industrial fourth industrial revolution, basically they involving the creativity in the industry, designing, manufacturing, development, research, business model, and supply chain to optimize the new technologies for manufacturing processes. And the most important thing is to combine intelligent manufacturing machine with the IT sector to create smart factory for intelligent products or creative products or customized products. Basically, this type of products are mostly useful in the aerospace industries. then automotive industries, medical industries, defense industries, likewise. So the basic idea of the fourth industrial revolution is to develop a smart factory by amalgamating the different advanced technologies like additive manufacturing, Internet of the Things, artificial intelligence, and robotics. So, if you see in detail, so there are different components of the industry 4.0, like additive manufacturing, smart machines, advanced autonomous robots, smart materials like safe memory alloy material, different smart materials may be useful to as per the application, like shape changing, color changing, property changing as per the different conditions. Then internet of the things, industrial internet of the things, smart sensors, PLC, various advanced softwares, then virtual reality, augmented reality, then cloud, OPC server, and artificial intelligence. These are the different smart technologies. By amalgamating all these technologies for development of the product using smart manufacturing ways. So these are the different components. So I will focus only on the additive manufacturing related to the industry 4.0. So you might have seen 3D printing or additive manufacturing in your colleges or various industries. Nowadays, they are very much popular for development of the various products, not only for the direct using into the application for development of the prototypes in your day-to-day activities or development of the products related to your projects. You might have seen this type of 3D printers. Nowadays, this type of 3D printers mostly for the FDM based technique, that is fused deposition modeling based technologies, in which various thermoplastics or polymers you can use for the development of the object. These are very popularly available in various colleges and organizations. The basic objective of this development of the 3D printing is the customization. You can develop any product related to your choice. Whatever you can design, that can be very easily fabricate by using this type of 3D printing technology. So the role of the additive manufacturing in industry 4.0 is the customized product development. You can design and develop the product whichever you want as per your choice in variety of materials available, even though there are limitations of the material. But what nowadays there are different types of materials are available. By using that material, you can directly use this product in the end application. You can develop a prototype rapidly for the testing purposes, various R&D processes. When using the rapid prototyping or additive manufacturing, the actual inventory is not needed. In virtual inventory, you can save your CAD files, you can share that CAD file, you can share to other customers or other manufacturer vendors. So that is the advantage of this technology. Many times you can reduce the wastage, which may be more in the subtractive manufacturing. In many additive manufacturing, you can recycle the material and use it again for the further development. Nowadays, speed of the additive manufacturing is very high, and it goes on increasing for the bigger parts. Different type of technologies day to day involving in the development of different additive manufacturing, by which the speed is going to increase. Not only the speed is increased, along with the maintaining the accuracy of the part. Then as per your choice, you can design, develop a product. You are flexible to develop the product in your uh, required material for required application. You can reduce the risk. Suppose you develop a part for medical application, so before actual performing the surgery, you can develop the part and show you to the customer. You can practice on that particular part, so it helps to reduce the risk in the surgery. Then by developing various artistic model, various product accuracy, quality, you can give a customer satisfaction. As per the technology advances, the product are more accurate using the 3D printing technology. Again, various parameters depends. It depends on how you are using 3D printing or additive manufacturing, by which you can maintain the accuracy. It is mostly depend on the layer heights. Then again, extruder you are using, whether it's a powder based technology, then again different parameter, speed, temperature, this. So based on this different parameter, you can achieve a very good accuracy also in the additive manufacturing technology. It helps to improve the productivity, also profitability. There is a actually no need of supply chain performance. You can directly give your product to the customer, so it helps to reduce that particular cost related to the supply chain. And most importantly, these different roles of additive manufacturing related to the industry 4.0, you can use this in a various industries like medical, engineering, aerospace, automobile, defense, various artistic works, jewelry, so then toy manufacturing, and other related sectors. So because of the advancement and this type of different additional features like customization, flexibility, this additive manufacturing is a important part in the industry 4.0. Another thing is that nowadays there is a huge advancement in the additive manufacturing technologies. Like nowadays, you can directly manufacture your part by using various metal additive manufacturing technologies like DMLS, direct metal laser sintering, then SLM, selective laser melting, by which you can directly produce part in variety of materials. Like suppose in a biomedical industry, for development of the various types of implants required for the various complex surgeries, in a biocompatible material like titanium Ti6Al4V, then cobalt chromium, then stainless steel 316Cl. So these type of materials as well as additive manufacturing technologies are available nowadays. So by using these technologies, one can directly produce parts in a required biocompatible material. You can perform coating on this implant for that particular tissue engineering purposes of cobalt chromium material, and you can directly use this type of 3D printed parts into a actual surgery. So that this is the advancement in additive manufacturing technology. Also, I have already told different materials, that is smart materials are also available. You can directly print, so as per the requirement they can change their shape and properties as per the temperature and other environmental challenges. They can change their shapes and properties. So this type of materials are also available. Different biodegradable materials are available. By using this, you can directly develop a scaffold and use it into the surgery. Also, whatever the printers or additive manufacturing technologies are available nowadays, they are trying to increase the speed of that additive manufacturing with the maintaining the proper accuracy, so that within a less time we can get particular object and use it into a actual application, maybe into the surgery or in different application. And again, another advancement in the additive manufacturing technology is the bioprinting. So in the bioprinting nowadays, research is going on. You can directly print your organs using 3D printing or additive manufacturing technologies like your heart, skins, and other. The research is going on. You can directly print the bones whenever required, maybe in the cases of the accidental cases or in various surgeries. So you can directly print bio printing models or organs using this type of material. So these are the some advances which are included related to the additive manufacturing and playing important role into the industry 4.0. Apart from this, there are various challenges also, like material limitation. There are limited materials available, but research is going on for newer material for various application. Also, there is no proper standard relating to the quality control. Peoples are working on this uh, uh, re- in various sector. Different quality controls are required, and peoples are making research related to that. Then speed and scale. The huge part manufacturing is quite challenging in the additive manufacturing technology. But again, this is again a important challenge related to additive manufacturing. Another one is the we are very much flexible for the designing of any part, but related to the additive manufacturing designing is very much um, not only complicated, but that needs skill. So designing related to the additive manufacturing is another sector, and that needs to be properly channelized so that proper designing can be produced for the development of the part using additive manufacturing. That is one important challenge related to the additive manufacturing. Another one is the standardization. For while production of using additive manufacturing, the standard procedure, standard parameters required for additive manufacturing to get a ultimately quality part related to the particular application, that is again missing, and required various research related to this sector. So these are the various challenges related to the additive manufacturing. Now, these are some basic theories related to the Industry 4.0 and related to the additive manufacturing. Now, my next part of the presentation is the how this additive manufacturing particularly useful into the Industry 4.0 and basically into the medical sectors. So, in this particular thing, you can see this is the generalized procedure of development of product related to the additive manufacturing and used mostly into the surgeries. So it has been divided into four different categories. One is the first part is the it requires scanning. Then scanning means it requires a CT scan, MRI scan, or you can directly design the part by using taking the manual measurement and other things. This is the first part, which is very very much essential whenever designing of any part or implant related to the medical. Second one is the CAD. After scanning, after taking the raw data from the patient, next thing is the CAD designing by using various CAD softwares like Froi, Katia. Whenever you talk about the medical sector, there may be required some medical compatible, biocompatible or biomedical compatible softwares by which you can convert that CT scan or MRI scan, which are available in the DICOM format, into a STL format for further designing as well as the 3D printing. So in the CAD section, you have to convert your raw data, that is CT scan data or MRI data, into a useful CAD data. Then by using different biomodeling software, you can process this data and perform virtual surgical plan. In virtual surgical planning, you have to decide what is the size of the tumor, what section you have to cut, what will be the design shape of your particular cutting guide, what will be the shape of your implant, where to perform the cut, then finite element analysis to check the design of the implant and the surgical guide. This all process has been conducted into the section of the CAD in the second step. And once it is approved by the doctor from this CAD files, the next step is the actual additive manufacturing. So as per the requirement, if you are developing the implant in a metal, biocompatible metal, so it required the metal additive manufacturing for development of this type of implant. And if this is a cutting guide for accurate resection of particular bone tumor, if you want to develop the particular custom surgical guide, so you can develop it in a polymer. Again, a biocompatible polymers are available into the market. By using this polymer, by using this general FDM technology, you can develop this type of particular surgical guide, and this implant and guide you can very easily after sterilization use into the surgery. So this is the complete chart from scanning to the surgery, where the role of virtual surgical planning, CAD softwares, additive manufacturing plays an important role. So you can link this particular process with the industry 3.0, where they provided the flexibility they using various 3D printers in industry 3.4. But in a industry 4.0, what they did, they are doing a smart manufacturing. Whatever I have told you, scanning purpose, CAD purpose, then additive manufacturing process, then surgery, they have performed separately. But nowadays, in a era of industry 4.0, people are directly designing this type of parts, this type of custom surgical guide, this type of customized implant directly in the hospital. So, as per the requirement of the patient, surgeon by selecting some initial parameters in the software can directly design this type of custom medical implants as well as the custom surgical guides as per the requirement. And using the additive manufacturing technology, once it is designed, done, and approved by the doctor, very easily they can fabricate this type of part in hospital only and directly use it into the surgery. So that is the advancement of industry 4.0 as compared to the industry 3.0. Now I will again explain you how this particular customization and flexibility plays important role in the medical sector, where additive manufacturing plays an important role for the development of this type of products. So this is another very important device. I will show the same device and the different applications of this particular device, custom surgical guides in various surgeries, where the role of this additive manufacturing plays important. Okay, so this is the device. The name is called as custom surgical guide. The basic use of this device is for accurate drilling purposes. You might have seen this type of device which are useful in the dentistry, and the major use of this device is to accurate placement of the dental implant. So this is the type of drilling guide. The second one is the cutting guide. Whenever the accurate cutting is required in a surgery, so this type of cutting guides are useful. And third one is the positioning guide. When to combine two resected bone on a particular position, this type of positioning guides are useful. So these are the examples of custom surgical guides only. The main and same thing in all the three components is that they are, all the three are the custom guides. So without using additive manufacturing, it is not possible to fabricate this type of customized parts which are required into the surgery. Again, the shape and size of this type of particular devices are very much complex, and you cannot measure directly by using regular ruler. Okay, so by development of this type of parts, here the role of additive manufacturing is very important, which we have already discussed. The flexibility and the customization, these two important parameters are related to the additive manufacturing. We can see in this example. So the first surgery is the dentistry. You can see this type of custom surgical guides. Basically, these are the drilling guides useful for the accurate performance of the drill into the maxilla as well as in the mandible side, for fixation of the accurate, for fixation of the accurate implant, for fixation of the accurate implant into the maxilla as well as the mandible. So these are the example of the drilling guide. So as per the virtual surgical plan, as per the requirement, surgeon can design this type of parts, and by using the additive manufacturing technology, they fabricate this part, and after sterilization, they can use this surgical guide or drilling guide into the surgery for the fixation of the dental implants. Now, in this particular figure, you can see they have also fixed the metallic part in the drilling guide, in the particular drilling path. So this is another thing, how this plastic and metal are perfectly fixed. So in that particular case, that metal sleeves have to be fabricated separately, and then you have to insert it into the particular plastic part. So these are two separate processes of polymer fabrication as well as the metal fabrication. So two different technologies are required, different additive manufacturing may be required for the development of this type of two different parts, and then assembly of these two parts and then use it into the surgery. Another one is the, you can see again it is related to the dental side. This is another type of custom surgical guide. In the cases of orthodontic treatment, you might have seen the fixation of the braces, fixation of the braces. They must have to fix this C tube on, and the requirement of fixation of this C tube must be on the proper location. So what they did, they have designed this type of complex surgical guide. You can see there is a arrangement provided for the cutting location, and this particular part is for the fixation. This is the base surface of the surgical guide, which is useful to fix into the dental side. By taking the advantage of this particular negative section, they can fix this particular guide over there, and as per this particular slot, they can perform the slot cutting slot over there. They can perform the cutting operation over there. Once they perform the cutting operation, they have cut this particular cutting section of the guide. They have cut this particular cutting section of the guide and perform the drill using this C pin, and very easily at a required location, after twisting of this particular C pin at the planned location, they can perform the drill over there and fix this C tube mini plane. So by using this simple device, by using this simple device very accurately, it is possible to fix this type of complex C tube exactly on the plant location. What is the advantage of this particular device? It helps to properly fix these braces in a orthodontic treatment. So it helps to improve the accuracy of this orthodontic treatment. Also it helps to reduce the surgery time that we actually want by using this type of advanced technologies like additive manufacturing. That is the purpose of this industry 4.0, so that you can directly design and develop this type of part in a your hospital or in a clinic directly without taking the help of any other person or the other expert. Another guide, surgical guide, which are useful for accurate resection of the mandibular tumor. You can see that this is the example of the cutting guide. So this is the custom surgical cutting guide. So you can see, for accurate resection of the mandibular tumor, this type of cutting guides are useful. Many times after resection of this particular mandibular tumor, they have to fit something over there, maybe customized implant. If they design an implant to replace this tumor, so they can fabricate this type of implant by using any additive manufacturing, metal additive manufacturing technology. Or otherwise, second thing is that they can use the fibula bone which is available in your leg. So they can use the fibula bone, they can cut this fibula bone in a number of pieces and arrange them as per the requirement and perform the surgery and replace the tumor with the fibula bone. So for accurate cutting of the fibula bone, this type of custom surgical guides are useful. This type of this particular figure is for the showing the device which are useful for accurate resection of the fibula bone. Then further, this fibula bone is useful for the surgery of the mandible. So both the cases, these custom surgical guides are example of the cutting guide. You can see another very complex surgery. This is called as the Lee Fort 1 osteotomy. In many cases, people need this surgery for the adjustment of the maxilla bone as per the shape of the mandible. Many times you might have seen that the front teeth of the maxilla are not properly matches with the mandible section. So in that case, they perform a cut from the maxillary side, and this particular surgery is called as Lee Fort 1 osteotomy. You can think that if they perform this particular cutting without using this type of surgery, so there may be chances of improper cutting of the bone and hamper the accuracy of the surgery. So in that particular complex surgery, this type of simple device, again, not only simple but complex design, which only possible to fabricate by using additive manufacturing, can play a very important role in this type of surgery. So by using this type of surgical guide very easily, just by fixing over there and performing the cut using the design slot, they can very easily perform accurate cut and perform the surgery. So this is again the example of custom surgical cutting guide useful in the craniomaxillofacial surgery. This is another customized design of custom surgical guide. Here, this particular nut and bolt type of arrangement, this particular device is called as the distractor, and many times for lengthening of the bone or shortening of the bone, this type of nut and bolt type of arrangement called as distractor are useful. In that particular case, accurate cutting of the particular bone from both the sides is required so that symmetric distraction can be possible. So in this particular case, the requirement is that accurate resection of this particular bone from the particular location. So in this case, this type of custom surgical guides are useful. These are the custom surgical guides, again example of the cutting guide, and again development by using the additive manufacturing technology. Now nowadays, people are developing this type of custom surgical guides are also from the different metal additive manufacturing. Why it is so? Because when they produce the particular custom surgical guides in a metallic one, the thickness of the custom surgical guide they can decrease because of the high strength of the material. If they are producing the same device using the polymer, the thickness should be more than 3 to 4 mm. Then only it can sustain the cutting tool, vibration of the cutting tool. Otherwise, they will break. So to reduce the thickness of the particular device, they can directly use the metal additive manufacturing, which helps to reduce the thickness of the particular device and improve the compactness of the device, which actually needed into the surgery. They always needed compact devices for the surgery, and where the role of metal additive manufacturing is important. You can see the another complex design of the custom surgical guide, which are useful again for the accurate resection of the mandibular tumor. You can see the design of the device has been changed as per the requirement, and again easily manufactured by using additive manufacturing technology. This is another design of the surgical guide only, but this is a use into the orthognathic surgery. This is again a surgery related to the shortening or advancement of the chin bone. So in particular cases, those who having a shorter chin or longer chin, for accurate adjustment of the chin, this type of custom surgical guides are useful. The purpose of this guide is to accurate resection of the chin portion, and as per requirement of the shortening or lengthening can be possible using this type of particular device. Again, the complexity is the development of this type of particular device using any traditional method is not possible. So here is the role of additive manufacturing. The customization is required, as well as the flexibility is playing the important role. Flexibility of the material, which sort by using the additive manufacturing technology only. This is another type of device. Again, it is related to the surgical guide, but it is not a cutting guide. It is the splitting guide. Instead of cutting by using any cutting saw, they using a hammer and chisel to split this particular bone from the sagittal plane. Okay, so they have provided two retractor. By just pushing these two blades, they can fit this device over the mandible for particular fitting, and there is an arrangement they provided. So just fixing the chisel over there, and just by hammering the on the chisel, they can split this bone from this particular side, and by adjusting after splitting, just by adjusting the length of two bones, they can perform the surgery, means shortening or lengthening of the bone. So in this type of particular surgery, that is called as sagittal split osteotomy, this type of custom surgical guides or uh, um, custom surgical guides are useful. Again, the development, you can see the very thin wire like structure they have provided in the design. So in this type of particular design, development of this type of device by using any polymer is not possible. Even though it may possible, it will, but it will not work into the surgery. So there is a role of additive metal additive manufacturing. By using this type of customization is possible. Again, another design and example of custom surgical cutting guide useful in the fibula flap surgery, which I have discussed earlier. The cutting of the mandible bone. In this case, they have used the cutting of the bone in a stepwise manner because that was the requirement of the patient. So, designing and fabrication is possible by using additive manufacturing. Another important thing is that instead of using the customized implant, they prefer the fibula bone. So fibula bone has to be cut into a number of pieces to obtain the alignment of the mandible. So there is separate guides are required. So all the guides for mandible as well as the fibula bone, they can be manufactured by using the additive manufacturing or additive manufacturing technologies. Another application of this customized device is a in the total hip arthroplasty, where this type of surgical guide, these are the example of the drilling guide and mostly useful for the drilling of the this particular bone to pass the particular pin from exactly from the center of the head of the this particular femur bone. Okay, so this particular device is called as custom drilling guide and mostly useful in the hip arthroplasty. You can see here better. This particular red one is the pin has to be passed from this particular head of the femur bone complete from completely. Again, another requirement is the accurate resection of the head. So this is the design of the surgical guide. It is a combination of two guide. One is the cutting guide as well as the drilling guide. So this type of complex device can be possible to fabricate by using additive manufacturing technology directly. This is another design of the custom surgical cutting guide to cutting the head of the femur using this custom surgical cutting guide. This is another design to, this is the example of the drilling guide to perform the accurate drilling in the acetabular side. So this is the example of the custom surgical drilling guide. Another one is the, you can see this is particular the acetabular bone and accurate cutting of the tumor on the acetabular side. This type of cutting guides are useful. In the total knee orthoplasty for the accurate resection of this tumorous part, you can see the design of the custom surgical guide. This is again the example of the cutting guide, and you can see how accurately it is possible to cut this particular bone as per the requirement by using this type of custom surgical guides. So that is the importance of this customization and which is possible by using this additive manufacturing only. This is another example of the cutting guide useful in the knee orthoplasty by cutting the two bones in the joint, upper bone and the lower bone. So these are two different guides. As per the requirement, they can design, develop and use into the surgery for the accurate resection of the joint in such a way that that knee implant can be accurately fixed into the joint. Another example, that previous one was the cutting guide for bone cutting, and this one is again for the knee orthoplasty for the drilling guide, that to make a drill to fix the knee implant at the joint. So these are the example of the drilling guide. Again, the complex design developed by using additive manufacturing. Another application of the surgical guide, custom surgical guide, again it is the example of the drilling guide in the case of the scoliosis. You can see this red one figure. This is the example of scoliosis. Scoliosis means the this bending of this particular backbone or the vertebral column. So in that particular case, surgeon has to fix some nails inside this particular bones, various lumbar bone or other bones. And by this particular, you can see better in this figure, you can see this type of nail they have placed from this pedicle section. This particular small region or narrow region is called as the pedicle, and the complexity is that the surgeon has to pass these nails accurately through this pedicle. If if these nails unable to pass accurately from the pedicle, and while transferring this nail from this particular channel, if they hit to the vertebral column, so there may be chances of the um, there may be chances of anything, brain hemorrhage or any other thing, or um, any other problem may arise because of the if this particular nail touches to the um, particular section, or what you can say. um, So this is the important thing, is that how to transfer this particular nerve exactly from this pedicle section to avoid this to the touching this particular to the vertebral in this narrow section of the vertical column. So accurate transfer of the nail is important. So in that particular case, this type of custom surgical guides are playing a very important role. You can see the design of particular device, the shape of this every vertebral column bone are different. So in each bone you have to design it separately and manufacture it separately and use it into the surgery. Okay, so here playing a role of this customization is important, and that is only possible by using the additive manufacturing technology only. Again, another example, that is the corrective osteotomy. In many cases, accidental cases, there may be requirement of the accurate cutting of the bone. In this case, this type of custom surgical cutting guides are useful for accurate cutting of that crushed bone and fixation of the implant. You can see another example, that is the bone tumor resection and graft preparation. After recutting of the particular tumor, they have to produce some graft from different entity or from different bone. So for development of this type of graft, this type of custom surgical cutting guides are useful, and cutting of this type of particular tumor, this type of custom surgical guides are useful. So both are the examples of the customized cutting guides. You can see the effect of when you using a custom devices into the surgery in the lower two figure. First figure showing the manual cutting, another figure showing the cutting by using the custom guide. So very easily you can see the accurate cutting is possible only by using the custom surgical guide, which is not possible by manual cutting method. So this is the importance of this device useful into the complex surgery. You can see another example. Here again example of the accurate resection of this particular bone by using this custom surgical cutting guide. By using this very easily, accurately cutting is possible, and fixation and development of this type of graft and fixation of this graft onto the particular location accurately is possible by using this custom devices. So that is the role of customization, and which is possible only additive manufacturing. Another example and very complex surgery is the orbital implant placement. In the case of orbital implant placement, you can see the lady required orbital implant placement. This type of custom surgical guides or custom surgical drilling guides are useful. Here are the provision for placement of the particular implant at the planned location is incorporated into the device. Now at the time of surgery, surgeon has to fix this particular device over there and just perform the drilling operation. So all the plan has been incorporated this customized devices, and this device has been produced by using the additive manufacturing technology. and use it directly into the surgery. Another example is the metatarsophalangeal joint, that is the fingers of your leg. So many times in some people require the adjustment of those bone, um, because of the improper shape, or this particular disease is called as the holus valgus. In that particular case, then people needs the twisting of the bone. So for twisting of two bones and make it parallel to each other or proper position, this type of twisting is required. And for this twisting, this type of drilling guides are useful. So from this drilling arrangement, they pass this particular nail, and by twisting these two particular fingers, they adjust the finger as per the requirement. So that is the again example of the drilling guide customized. It is also important to play a role in the neurosurgery. Many times in the neurosurgery, to stimulate the brain, this type of devices are useful. So this is the raw design, again possible by using the 3D printing or additive manufacturing only. This red one is the reference. They are using a face mask, then different attachment. And this last one is the needle holder. This needle holder they provided to fix the particular stimulus, and by using this stimulus they activate the brain. So this is the particular device, again called as the surgical guide or custom surgical drilling guide, useful into the neurosurgery. This is the, again, advanced design of this particular surgical guide, which are useful for the drilling purposes into the neurosurgery. You can see how accurately by using this particular device they can target the particular portion available in the brain by using this particular device only. Otherwise, to target this type of particular section in the brain, they required a robotic surgery or navigation technology, which is very costlier as compared to this to the additive manufacturing technology. And the more advanced design is this one, and these are people are using this type of devices into the neurosurgery. Again example of the custom surgical drilling guide, useful into the neurosurgery to activate the brain by using a various stimulus. This is the example of the custom surgical drilling guide. So these are the various applications where most of, in all the surgeries, customization, flexibility of the material plays a very important role. Because of the complex shape, it is not at all possible to fabricate this type of custom surgical guides by using any traditional methodology. They only require additive manufacturing technology. And whatever the I am shown to you in the revolution, or in the third revolution, all these, that is designing, development, fabrication, they have performed separately. But in the era of industry 4.0, where we are expecting a smart manufacturing, we are working for the smart manufacturing. All these facilities nowadays people are incorporating in their lab only, hospitals only, or organization only, so that surgeon clinicians can, as per the requirement, directly design this type of devices, develop this type of devices, and after sterilization they can directly use into the surgery. Again, very important advancement in that is that they can develop this type of part in their required material also, like biocompatible material. For implant they are using different metals like titanium, then cobalt, chromium, stainless steel. And for the particular surgical guide, different biocompatible polymers are also available. So just by setting some parameter, different softwares nowadays, and these softwares are AI based software. By you taking the help of AI, they have directly designed this type of particular devices by setting some parameters only, or minimum parameter, and directly fabricate this part in house and use it into the surgery. That is the role of industry 4.0. And the tool additive manufacturing is important in the industry 4.0. Why this type of customization is needed? If they are, we are using it into the surgery, the main component or main parameter of using this customized device is that it helps to improve the accuracy of the surgery, it helps to reduce the surgery time, it simplifies the surgery, and most important, whatever you have designed, whatever you have planned, this simple devices having the capability to transfer this plan to the actual surgery. That is the advancement of this device in a minimum cost. Otherwise, to obtain this type of particular accuracy, then navigation technology or robotic surgery playing a important role. So as compared to this less costlier device plays a very important role. apart from this apart from this particular custom surgical guide, people can design this type of anatomical models. The people having a different mm, tumorous parts or tumor or different traumas. So actual before actual surgery, this type of anatomical models can develop, which helps to reduce the complexity of the surgery. Surgeon can practice on this model and perform. After practicing, they can confidently perform the surgery, actual surgery. These are again can be possible to develop by using additive manufacturing. The virtual surgical planning plays important role. So by using the help of software, you can design it into the software, various surgeries, you can plan the surgery, you can design custom surgical guide, medical implants. This can be possible. Then custom surgical guides for various surgeries, which we have already discussed. Various types of customized implants can be designed. These are related to the mandible side, cranial plates, metatarsobalancite, ear implant, and other implant can be directly possible to print in variety of material. Nowadays, different polymers are also available for development of the implant. You can place this type of implant developed by using the polymers into the patient's body, like peak material polyether ether ketone. This is biocompatible material and having the strength equivalent to the metal. So these are the advancement in the additive manufacturing sites. Then you can perform finite element analysis on the anatomy to check the design of the implants. You can develop various adjustable devices for various surgeries. Again, nowadays different materials are available, 3D printing materials are available. The application of these different 3D printings are like from industries to engineering, aerospace to the medical sciences. We also having the facility by which from industrial grade material to the high performance grade material like metal field pick, that facility is also available, and people are using in various applications. Different biocompatible materials which are useful mostly in the dental side for development of surgical guides, then splints. These are available in the market. These are the advancement of additive manufacturing. Now, and again, reverse engineering tool, that is 3D scanning, by which you can directly develop a part or CAD design just by scanning the object is possible by using the 3D scanning. That is again an important tool in the revolution, or in the fourth industrial revolution, by which you can directly get the 3D CAD model, and then by using additive manufacturing you can very easily print it. So this is from my side. Thank you very much. If you're having any question, please ask.
Thank you, sir, for your nice presentation. All the audience are requested, if you have any question, kindly raise your hand. The attendees, do you have any question? You can raise your hand. I will allow to speak. Sir, I think no attendees have any question. Sir, thank you very much for your nice presentation and the deepen the knowledge in the field of biomedical and biosciences in the context of additive manufacturing. This is a very wonderful presentation, and you have really deepened the knowledge in the field of additive manufacturing. And thank you on the behalf of Opijindal University. And sir, see you in very near future for your presentation, sir.
Thank you very much for this opportunity. I have told that my experiences is related to biomedical side, but whatever the customization and flexibility, materials, additive manufacturing, almost similar type of applications are involved in the engineering side,
Yes, sir.
then as well as other aerospace side, then automotive sector. They need a customization, so so they can use